Welcome back. Welcome back to our fourth mobile talk for today. My name is Alin, for those who attended and joined late. I'm leading the mobile and AI communities, and I'll be your host today for this last talk from the Romanian side. Next, US will wake up after hours, and you can join for another two awesome mobile talks later today. So, I'd like you to introduce Radu, one of our senior Android developers in the mobile community here in Romania. Radu is also one of our community leaders, and he is driving all the knowledge sharing activities for our mobile community in Bucharest. Radu is passionate about clean and scalable architecture, and lately around Jetpack Compose and modularization. So he will present us some best practices and some concepts that hopefully you can use in your day-to-day activities and in your projects. So Radu, the scene is yours. The floor is yours. The Zoom is yours. The YouTube is yours. So go ahead.
Thanks, Alin. We're going beyond Zoom now. So hi, everyone. I'm Radu. As Alin said, I'm mobile community lead here at Cognizant Softvision. I've been doing Android for more than 10 years now, more than 6 of them here at Softvision, where I'm responsible for leading an awesome group of people here. I'm very proud to work with these people. I also like the academic side of things. So I'm also a teaching assistant at my local university here. So ruining the lives of students for a couple of years now. And I like the best of both worlds. I like bringing research to development and development to research. It's always been a pleasure of mine. Also, I think it's my 4th or 5th time speaking at Programmers Week, and I'm super psyched about the traction that this entire conference is getting. So you can't imagine how it was a few years back when we were a couple of people, crouching around some screens and talking to each other, and now we've gotten to this point, and I'm very happy about this. I also have my co-host around here somewhere, my dog. You'll probably hear him barking whenever he disagrees with me. But now enough about us, and let's see what we're going to be talking about today. So I'm a big fan of clean coding. So we're going to talk about what components are, why do we need them, what does clean components even mean. So a lot of theory. If you've seen Alex's previous presentation on KMM, that was super practical. No, this one today is super theoretical. And we're going to bring all of these concepts and see how they work into Android development. So prepare for a snooze fest, because this is going to get super boring from now on. Now, moving forward, we're going to start with the theory, as usual. Told you I'm a big fan of clean code, and you can't start writing and designing quality code without properly understanding the solid principles. So I'm going to quickly go through all 5 to make sure that everybody has that, basic fundamental engineering principles. So you've got single responsibility principle. This translates to a class or a function should have a single reason to change. This is how I want you to look at this principle. Then we have open-close principle, which means that a software artifact should be open for extension, but closed for implementation. This translates to create proper abstractions, and this will lead to very good software. If you give them proper responsibilities and create this way in which you want to extend software anytime your requirements change, instead of having to grossly rewrite it, then you're on your path to a proper architecture. And now, if open-close principle promotes inheritance, then Liskov substitution promotes substitutability. Very hard word to pronounce. So this actually adds constraints on inheritance. It's not just creating those abstractions, but making sure they work. If you extend the car and when you start the engine, it blows up, you've made some terrible decisions along the way. Next up, it's our interface segregation principle. And this means if you create a contract, make sure that everybody that uses the contract needs all of the contract, if not split it up into smaller contracts. And last but not least, it's actually my favorite, it's dependency inversion, which means you should never care about concrete details. You should only care about concepts and abstractions. And this can lead to very good software design. Now, why I like dependency inversion so much, you'll see that it helps us get out of sticky situations, and we're gonna get a handle on them soon. So the bottom line is what we want to drive for is stable abstractions. Now we have these two concepts that I'm introducing, stable versus volatile and abstract versus concrete. And it's very important that we understand that. If something is stable, it means that it has very few reasons to change and it seldomly changes. If something is volatile or unstable, it means it changes all of the time. Don't get me wrong, it's not wrong to be unstable. I'm the perfect embodiment of being unstable, so there's nothing wrong with that. Being unstable means you change often, and it's good to have components that change often. Now, moving on to the abstraction side, we all know what abstraction is and what concretion is. It's the difference between a contract and the details of that contract, right? So we need to understand that when an abstraction changes, and they should seldomly change, all of the concrete implementations that derive from it will change. So it's a high impact thing, right? When a concrete implementation changes, it doesn't usually need to modify the abstraction itself. So it's just going to change its details. And if you don't look at those details, you really don't care. So this is why we want to drive towards stable abstractions. And there are a few rules that we need to talk about. So if you have a volatile concrete class, don't refer to it. Refer to it as its interface, as its contract. And if you want a small example of this, if you need a list of items, just use the list interface. Don't tell everyone you're using an array list and mark this as a dependency. People really don't need to know these details. Only if you want to enforce some strict rules around this, then don't. If you have security requirements or, I don't know, performance requirements, then okay, that's part of the contract. If you don't, be more abstract, be more conceptual. Second of all, don't derive from volatile concrete classes because they're going to change often, and then you're going to have to change everything that derives from them. And the third one, you might super disagree with it. It's don't override concrete functions. And you'll be like, Radu, you just told us about open-close principle. Yes, but open-close principle does not say everything you extend needs to be concrete. You need to think about abstractions. So if you see the need for overriding behavior, maybe you should start extracting a contract and have it implemented by these two and start using interface segregation to define those responsibilities. Because when you override a concrete function, you inherit all of its dependencies. And even though you don't use them, you still inherit them. So be very careful with overriding concrete functions, okay? And last but not least, this is the Voldemort rule, the name of the class that shall not be named, right? Don't even think about concrete and volatile classes. Just wrap them around abstractions and think about them that way and don't refer to them in any way. And you'll be a lot safer. Now let's move on to components. So we were talking about what are components. They are these units of deployment, these small entities that have to be deployed as a part of the system. And in Android, we know them as Gradle modules or libraries, and we link them together and we get our big single executable, which is the APK. So why do we want components? Well, libraries, right? Can you imagine modern Android development without libraries? Because if I started the project without Retrofit or Cater or without Room or SQL Delight, I'd be, wow, I really don't want to implement these. So yes, we do love libraries for what benefits they bring to us. We need to understand what clean libraries are. Now, what we can do when we start splitting our work into components is that they can promote, if you build them correctly, development independence. We can split up the work and have these separation of concerns where people can work independently and from time to time breach that gap and make sure they're compatible, right? They can also improve isolation and we can hide complexities behind components, which is great. Somebody using that component doesn't really need to know what it's all about. They just care what it does. And there are two things that are very important when we talk about components. It's cohesion and coupling. And cohesion means bringing together everything that makes sense into a component and splitting up everything that doesn't make sense into separate components, right? That means we're going to have dependencies. And this is where coupling comes into. When I have dependencies, I have reasons to change. So the more dependencies I have, the more reasons to change I have, and this makes me unstable. Maybe I'm not supposed to be unstable. So there's a clear compromise between the two, and we have to work towards, and I think you've heard it a lot of times, good software has high cohesion and low coupling, right? Because we want stuff that makes together to be together, and we want to reduce things that we depend on, so we're more independent. Now, moving on to cohesion, right? Bringing together things that make sense. That's a super vague thing to say. You stand up in a room and you say, I think these things make sense to be together. Maybe the rest of the room does not agree with you. So we need to set up some ground rules here on how we can enforce this and how we can guide towards better cohesion, right? So we have these 3 principles, and I'm going to talk about each one of them. So we can group for reuse, we can group for maintenance, and we can group to avoid unnecessary releases. And let's take each one of them at a time. So REP says that when we reuse code, it makes sense to release that code together, right? Because it belongs together if it's reused together. Now, this is like a super weak concept principle. It just it's the same as saying maybe they make sense together. So the useful thing about this is that releases need to be versioned. And this creates the system of versioning which gives us actually independence. We can choose when we want to bump our versions of the dependencies we use. So this gives us independence. It gives us choice, right? And I don't know how many times you've waited for the next season of your favorite show to appear, and compare that with the number of times you've waited for an update for a library you're using to fix that pesky bug that's been bugging us all along. Now, let's move on to some principles that give us a little bit more, right? So we have CCP, which is the single responsibility version of components that says, I will bring together all of the classes that change for the same reasons and at the same times. And I'll separate out those that change for different reasons and at different times. And this is something you can actually look when you're I don't know, updating requirements. If you have a component and you only change 2 out of 7 classes almost every time, but the rest are unchanged, that means you don't have high cohesion there. It means you might want to actually separate these. And it's good that we want to keep them together because they're maintainable, right? If they change at the same pace, then we're going to release at the same pace, and we don't have unnecessary releases all of the time, and we can maintain them. And it's also relatable to open-closed, right? Because when they change together in the same component, they don't affect other components, and they don't affect the extensions that come in to those other components, right? So it gives us a clearer view of how things should be grouped together. And last but not least, it's this common reuse principle, which is the ISP version for components, right? You don't want to bring code into a component that nobody or maybe only sometimes people need. So group together things and provide components that people fully reuse. If this is why retrofit does not include the JSON or the XML parser directly into it. I want the networking core, but I'm going to choose later which parser I want to use. I'm going to use JSON or XML. It's my choice. Don't force it upon me. Don't make me depend on things that might change and might influence me, even if I'm, especially if I'm not interested in that, right? And what you have to understand is that these 3 principles create this triangle of forces. And you are smack in the middle of this triangle, and they're all pulling in different directions, and you have to find the balance of your component. And this balance is found by looking at the technical, the political, or the business rule changes, and understanding the software is volatile, and understanding that priorities shift along time. When you start working on a project, you might want to group for maintenance. You want to keep the code there cohesive, so you see how it evolves, and you have faster release cycles, and you release more often, so people discover problems faster. But as quality starts improving and you become more stable, you want to start grouping for uses and maybe avoiding unnecessary and unneeded releases, right? So you'll have to understand that this triangle changes a lot, and you have to be prepared to adapt with it. Don't stick to what worked 1 year ago. It might not work today. Enough about cohesion, let's think about coupling. So every time we split up into components, it means that we're going to have dependencies, and our components are going to have dependencies, and their dependencies are going to have dependencies, right? So this is where coupling comes in. When we have a dependency to something, we're coupled to it because it's going to give us a reason to change. So there are 3 principles here that can guide us towards obtaining low coupling or better coupling. And let's see all of them, because each one brings its own stuff. So first of all, it's the acyclic dependencies principle, and which I think it's pretty clear for everyone. You should never have cycles in your component dependency graph, because this avoids and prevents morning after syndrome. And if you have no idea what morning after syndrome is, I'll just tell you a super relatable story. When you know you have that pesky bug, you fix it, you push a PR, it gets merged, and you go home and you relax. In the middle of the night, dev from US comes in and you broke his work while fixing yours. So he fixes his work and then breaks yours. So when you come in the next morning, you're like, this worked yesterday, but doesn't today. So this is the morning after syndrome. If we have cycles in our component dependency graphs, we're in big trouble. So this is why Gradle and a lot of build systems already enforce no cycles in the graph. And this is something that can be syntactically determined easily, and this is why Gradle does it. This doesn't mean that in your thought process and design process, you can't reach a point where you're going to need to have cycles, and you know you can. And this is where you're going to solve them by using dependency inversion. So this is where it comes in and saves our lives. Now, the second one is you always want to depend on something that's more stable than what you're doing, right? And this sounds good, but we need to measure it. We're engineers. How do we even start measuring this? And luckily, we do have a metric. We're going to measure instability instead of stability. So we have the fan in, and this is how many classes from the outside do I depend on? We have the fan out. How many of my classes are dependent upon by other components? And this is very easy to determine. Just look at import statements in Java or Kotlin, right? Include statements in C++ and C, and so on and so forth. And then we can drive to find out the formula for instability, which is fan out over fan in plus fan out. And this is normalized. It's between 0 and 1. If we don't have instability at all, it means we're stable and responsible. We don't really have reasons to change. Versus when instability is at its highest, then it's when we're irresponsible and super unstable, right? And it's easy to figure things out. So if my fan out is 0 and my fan in is greater than 0, then instability is going to be 0. So nobody depends on, everybody depends on me. I must be stable and responsible. If we make it the other way around, we get to an instability of 1, where I'm super unstable, but nobody depends on me, so it's cool if I'm unstable, right? And the constraint we have is that the instability of my components should always be bigger than the instability of my dependencies. And this means we should drive to depend in the direction of stability. And it's very important to understand that not all components should be stable. Stable means no reasons to change. And if a component doesn't have a reason to change, we have no reason to work, and we basically get fired. So you want to have unstable components, like your UI, right? Your UI should be able to change often to be able to reflect what users want out of it. But the business rules behind that UI should be stable. They shouldn't change at our whim. They should change after, I don't know, data-driven decisions, right? And as a side effect, it's going to be absolutely normal if you get components that are completely abstract. You can have components that only contain interfaces. These are your contracts, and everybody uses those contracts. So it's super okay to have them. And last but not least, we have the stable abstractions principle. If you remember, if you haven't dozed off yet, at the beginning of this presentation, I said we want to drive towards stable abstractions. And this principle says that the component should be as abstract as it is stable. And this is interesting, but we're going to have to see it to believe it. And first of all, we need to set up a relationship between stability and abstractions, right? If we do have a stable component and it is abstract, then it being stable encourages us to extend it. Being abstract, it's easy to extend. If it's unstable and concrete, like a UI, then it should be super easy to change, right? Nobody depends on us. We can change every time without affecting others. We're super concrete, so we're not changing abstractions, so we're not influencing anybody else through our changes. So this is what we want to strive for. So to measure abstraction, yet again, we have a super easy metric. We need the number of concrete classes in our module. We need the number of abstract classes in our component. And then we can compute the abstractness as abstract over concrete. And this is how we get a magical number, which we can use to start measuring the abstractness of our components. And now we have two metrics. Let's see how we can use them, because if dependencies should run in the direction of stability, and stability implies abstractions, then we have the dependency inversion principle for components, right? Dependencies should run in the direction of abstraction. You should always depend on things more abstract to you. So if we define this relationship as A over I, abstractness over instability, we get this very nice graph here. And in it, we have this main sequence. So this main sequence starts from something that is completely concrete, but very unstable, like your UI, and ends towards something super abstract, but completely stable, like your domain rules, right? So what this main sequence tells us is if a component is situated anywhere near this main sequence, it's not too abstract for its stability, so it can be extended as long as it's needed, and it's not too unstable for its abstractness. But what this also tells us is that we have two zones of exclusion. So we have the zone of pain. Nothing is abstract, nothing is unstable. So we have a super stable thing that cannot be extended. This is super rigid and difficult to change. And if you want an example of this, because not everything you use is not going to be in the zone of pain, you have the class string. String is final. You can't extend string. It's a utility class. You're going to use it everywhere. And it's in the zone of pain, but it's for good reasons, right? So this is a good example of things in the zone of pain, but I can't think of anything else other than utility classes being here. And then we have the zone of uselessness, where everything is completely abstract and nobody needs it. So if you've developed software that got into the zone of uselessness, I'm sorry, I know it happens. But okay, this metrics tells us where we are, but how do we drive decisions on refactoring? So what we want to do is compute our distance for every component that we have. Let's compute its distance from the main sequence. And then if we do a scatter plot of all of these distances, we compute the mean and the variance of this distribution. We can then look at how many components are at a distance that's smaller than one variation away. And those are acceptable, right? If they're in the realm of the standard deviation, then they're good. If they're outside of this realm, these are components that you want to start looking at because maybe you want to refactor them. And if you start refactoring them and you're super curious to actually measure these metrics, please include me in that because I want to see if your distance improves over time. So your distance should be getting closer and closer to the main sequence. And that's your goal, and this is how you can measure that. And for me as an engineer, this is awesome. If I have a way of measuring the performance of my design, I'm super happy. And this takes us to the layer or the onion or the clean architecture, where we take all of our components and we create these boundaries. These boundaries with their purpose, and their purpose is always to go from concrete to abstract and from unstable to stable. So we're going to have our concrete things like UI and DB. And by the way, if anybody here ever created let's say an abstract UI or an abstract DB and it worked, please reach out to me because I'm super curious to see it. If not, I think you understand why these are super concrete and they always need to depend on things that are less concrete and more abstract than them till we get to the gateways and controllers and presenters, and then we get to our use cases, which is our domain logic, and our entities, our business rules, right? So this is what we should strive towards, getting to this point where we have these rules on how to set up our components. We understand that dependencies should only cross the boundaries in this direction. We can't have cyclic dependencies. We should never go from the inside toward the outside. And if you want to visualize this, just imagine that all of these layers are tied together through strings. So if you pinch on entities and you pull it up, everything else should hang underneath it, just like an onion, right? Okay, so I think I've bored you enough with all of this theory. Let's go a bit into some maybe practical, but I think it's still going to be a bit theoretical things. So how can we start doing this for Android? Why we need to start doing this for Android is that most of us start learning Android strictly from the components, and we forget that we're engineers. We're not exempt from all of these rules. We should understand this. And I hope that this makes it a bit clearer why we should understand this. So if we talk about components in Android, they are Gradle modules. We know about them. Every project starts with that monolithic module called app, right? If we want to start designing and developing other components, we just need to create other modules. And Android Studio lets us do this. They are our single units of deployment, and an application can be monolithic based on your requirements. Don't get me wrong. There's nothing wrong about being monolithic, but when you see your design going crazy, that maybe you want to start splitting it up for, I don't know, developer independence or parallel development. And when we start splitting them up into these single responsibility components, they're still going to get linked and they're still going to become an APK. Now, what goes into a module? Well, you have a few configuration files. So you have your manifest. That's where you're going to put all of your permissions and the Android components you want to use and other constraints. You're going to have your source code and your resources and your assets there. And very important, you're going to have a build file, which configures this as an Android module. But don't forget about coupling, right? It also defines the dependencies of this component. And now, why do I say that Kotlin and Gradle are loved together? And it's not just because now we have Kotlin DSL for build files. And yes, that is super awesome if you want to try it out. Documentation may be a bit cryptic or missing, but it can help you do a lot of nice things. But it's that Gradle, actually Kotlin, shows an interest in components. And you've seen that we've lost the protected visibility keyword from Java. So we don't have it in Kotlin anymore. And it was for packages, right? But now we gained internal, and internal refers to modules. And this is where we see a pretty tight relationship between Kotlin and Gradle modules. And this helps us in hiding complexity. It helps us in defining these boundaries much easier. Now, when we talk about dependencies in Gradle, we have two directives that allow us to declare a dependency. You've got implementation and API. And if you want a super clear and concise definition for this entire table, implementation is non-transitive while API is transitive. So implementation is going to hide all of your dependencies from your dependents. They don't know about them, they don't care about them. And this is useful for hiding complexity, right? And for improving compilation as well. And this is when you want to use it when it's super internal to your module. Whilst API is useful when you're exposing dependencies through your API. So through your application binary interface. If you're exposing an interface, a class, whatever, to the outside world, and in its definition, in its functions, properties, or whatever, it has dependencies on other components, then that's your API. And you need to expose it to the outside world. And I think we should look at these examples to make it a bit more clearer. So if I'm designing a view model, I could use Rx Kotlin or coroutines internally, but I'm not exposing coroutines to the outside world. I'm exposing live data. So this means that Rx Kotlin or coroutines, they are not transitive. I should not use API. So my UI has no idea that I'm using Rx Kotlin and it's good, right? It shouldn't care. But live data, on the other hand, it's in my API. This is what I'm exposing towards the UI. So it's going to need to know about it. And please use this. Don't be the kind of component developer that wreaks havoc on people that want to use your libraries. And they have to play this game of, I'll try to recompile and see if this time it works or I need something different, right? if you look at data repositories, they could be using RX Kotlin internally, and they also could be exposing methods that return those reactive flows containing the data models. So this means that RX Kotlin is not like for view models internal. Now people outside of it need to know that you're using it. And so are those data models if you don't own them. If they come from a different dependency, then you're going to have to expose them through your API as well. Okay, enough talk. Let's look at the official Android app architecture. So if you go on Google and you search Android app architecture, this is the first link that Google gives us, right? So let's look at this architecture. We have our activities, our fragments, our UI, which are separate from our view models, and they use a view model, right? Think of these as instances, and these are references to instances. So an activity or a fragment is going to hold a reference to the view model. The view model holds references to live data and exposes them to the fragment or activity. It's cool that the view model doesn't know about the activity or fragment. This is MVVM. In MVVM, the activity should know who's presenting it. The presenters should have no idea who it's presenting. It's just exposing data through live data, through an observable pattern, right? Our view model is going to need data, so it's going to use a repository pattern, which is pretty cool because the repository knows about the model, which is room, and it knows about remotes, which is retrofit and the web, but the view model shouldn't care. Only the repository should care. And this is cool because this is going to allow you to refactor much easier. If you want to switch from room to SQLite, you can do it. If you want to switch from retrofit, you can do it. And it shouldn't influence your view model. So from this point of view, this super classic MVVM, clean-ish MVVM structure works, and it makes sense. I can already visualize a repository that's holding a reference to a database access object from room, so it can get that data. And you've seen an Alex's presentation too. And also this repository has a reference to the retrofit service, so it can fetch the data or upload it and so on and so forth, right? But is this architecture clean? We understand it, but is it clean after all of that theoretical discussion we have? Let's analyze it and see if we split them up as modules, because they kind of look like modules, right? Is this clean? So the activity depends on the view model, which means that the activity is concrete and unstable and depends on the presenter, which is, in this case, concrete, could be more stable, and it makes sense. I can change my UI, change the colors in my UI without having to change my presentation logic, which is pretty cool. So this one's good. It's okay. We could have this split into modules. And now my view model depends on repository. So this is your gateway, your use case, right? And it's fine. The repository is more abstract, right? And maybe less concrete. Maybe the view model knows only about an interface of the repository, not the repository itself. So this makes sense. And now we move on to this part where we just discussed it. It does make sense for the repository to have a handle on room and a handle on retrofit, but it's not really clean, right? Let's think about it. Are we going towards abstractness? Are we going towards stability? Because as far as I know, a database and a web service are as concrete as they can, and they are full of details, and they can be wildly unstable, right? We should be able to change them. So if we look side by side with clean architecture, we see that this link is actually broken. So we were here at the UI going to the presenter, then going to the use case. And if we were to trust this, it means that our database and network are our entities, and they are not, right? So where is this cognitive dissonance coming from? And it's actually from the way we look at things. It's supernatural for us, for the repository, to have a direct link to the database access object, but why does it need to know the details about that database access object, right? So the DB here in clean architecture is not your physical DB. No, it's the DB aware code. And this is what you need to understand. And this is where it might start to make sense. And the DB aware code should depend on the gateway. So if we have this broken link here, if you remember, what principle can we use to fix our architecture? And we talked about dependency inversion. Why don't I create an interface for this model, a contract, an abstraction, and the repository exposes it, right? And the repository says, this is what I'm expecting from a model. And now the model depends on the repository, not the other way around. And the model implements this interface. And now the repository will actually talk to room, but it will talk to it through this model interface. So now your repository has no idea why room is here and that room is here. It talks to a model interface. And this is good. This is actually what we're doing here. We're crossing the dependencies towards domain, towards stable and towards abstract. We can do the same for our data source. It's the exact same dependency inversion. And now when you look at it, this is the central part, right? The repository, your domain is the central part. So if you pinch your architecture and you pull it up, it's going to bounce off of repository and everything flows down from it. And it starts looking like clean architecture. And we haven't broken anything. We've decoupled it so nicely that right now I can change room with whatever I want, and you're never going to see it from repository to the top. And dependencies are going to flow in the dependency graph in the same way, right? So this is going to be, it's going to decouple a lot of things in your architecture. And what you can do now is that you can start doing this horizontal slicing, right? We're getting out of the monolith. How? We're defining the boundaries. And I'm going to have my features boundary, and then I'm going to have my presentation boundary, and my domain boundary, and my data boundary, and I'll have my DB and my network there. And they're all very separate. They're all hiding their complexities, and they're all driving towards stability and abstractness, right? And when you get to this point, each of these layers will make sense. They're going to have their single responsibility. They're going to have that single reason to change. And if you want to do it even better, you can start getting all of your business rules out of your view models and extracting them as interactors and use cases and defining those abstractions towards your UI. So then all of your domain logic, everybody depends on it. It doesn't depend on anything. And this is pretty cool because it means it can be pure Kotlin or pure Java. And this is what we want because business rules don't change based on, I don't know, our programming language. They should be the same. They are set in stone, right? And another thing that might be weird for a lot of people, and I got this question before, is why do I split up features from presentation? And the idea is don't take what I'm saying here for granted. Use what you think is useful from this. You can have a single module for features and presentations and presentation. So keeping your activities and view models in the same place. But if you want to do A/B testing, then you might have different UIs for the same presenter. So then it might start making sense to keep them separate, right? But it's up to you and your use cases. I can't tell you more than that. Another use case you can find here is, what if I want to build multiple products from my code base? What if I want an app that has feature 1, feature 2, but doesn't have feature 3, and one that has all 3 features? After I've done my vertical slicing, I can go even more nuts and do my horizontal slicing, right? And I can start splitting my data module into separate modules, multiple modules, and grouping them per component. So they're deployed per component. So the app module that's going to be assembling these can decide if it wants module 1 and module 3, and for a different flavor 2 and 3, and for the full flavor, the paid flavor, all 3 of them, right? This opens up this way for it. And it's going to be easier for you if you have single responsibility for and stable abstractions in your architecture. Now, a word of advice, if you start going down the route of components, make your dependencies coherent, especially your external dependencies, the one you want to grab from Maven and Google and so on and so forth, right? Make sure you're using the same recycler view across your components. That would be useful if you want to keep them, you want to keep them in check. And maybe recycler view isn't the best candidate because if you split them up vertically too, you can start refactoring just a feature at a time. So then you can start doing this. But if you're using coroutines, I'd suggest you have the same version of coroutines in your repository and the same one in your presenter if you don't want to get into trouble. So this is a super easy way where you can create your dependency version file and then use it across your build Gradle files. Another cool idea is to create your own Gradle plugin and make it more verbose. If you use Kotlin source, then it's even easier and cooler to do it. But nonetheless, this has saved me a couple of times from a lot of issues, and I hope it's going to save other people as well. And let's get to the end of this presentation. I filled your head with a lot of things, and it's time to see what our takeaways should be. So first up, and I couldn't stress this enough, keep solid principles in mind. It's going to help you so much to design clean designs and write clean code, right? Have this drive towards stable abstractions. Don't forget, stable abstractions means you're driving towards stability and you're driving towards abstraction. Keep this in mind. And always look at the balance between high cohesion and low coupling and keep it as good as it can get for you. Don't forget, we have ways of measuring it, so you can start measuring these. When we talk about cohesion, you have that triangle of forces. Respect it, understand it, and look at your priorities and see how you interpret it and play around with it. This is not, unfortunately, science. You'll have to figure it out on your own when either of these is more important. But it is normal for it to change with time. So don't get scared if it does. Having no cycles in your dependency graph should always be a thing that you have in mind, because Gradle is going to fail your builds if you don't. But remember, you can always use dependency inversion to resolve these violations, right? And last but not least, the main concept behind clean architecture is that your source code dependencies should always go towards your policies, right? UI depends on presentation, depends on policies, not the other way around. And if you enforce this, you're gonna reach a point where your architecture is boring, and boring is good. Boring means that whenever a requirement changes, it's gonna be super quick and boring for you to fix it. There's no more challenge in that. And this is what we strive for. And this is something that Alin has been pushing for a few years now. And in the end, I want to give you my final principle, which is the zero responsibility principle, or you can call it Radu zero responsibility principle, which says that any discussion on architecture is just a discussion. So you have to try to do these things yourself, and you're going to fail, and it's okay to fail. I failed multiple times, and the people I've worked with know how many times I failed. If you manage to fail fast, that's good. If not, you're going to learn from that experience. And I know I have overdid it and underdid it a ton of times. I'll have to be honest, and I never wrote 100% solid code, and I never think I will. But you should always strive for more here. So please take everything we've discussed with a grain of salt. Look at your requirements and see, do I really need this? And if you want, you can start playing around, because you've got those super awesome metrics. And I actually want to start looking if there are already some Gradle plugins or Android Studio plugins that allow us to measure those, because I'd love to see it in action and see if it actually pays off. But anyway, we have to give credit where credit is due. So most of this presentation is based on Uncle Bob's Clean Architecture book. And if you haven't read it, try it, because it's not going to be the kind of book that you read in 6 hours and you're a genius afterwards. I call it the Sunday book. Each Sunday, I grab a chapter from it, read it, try to see how I can adapt it to Android. And I go back to my projects and apply it and maybe reread the chapter again. But it has some very solid principles in it. And I hope that my presentation did it justice. And I hope it answered a few questions instead of raised more than one. But if you do have questions, please use the Q&A box for it. There's also a feedback form if you haven't fallen asleep yet. So thank you for your attention.
Great. So we have a question now. Should we have a separate module for the remote data setup that can be used by all the feature modules so you don't duplicate the code?
For your remote data setup, or
yeah,
so a configuration module for
setup. I know. Yeah, maybe it's
so I'm thinking it's a configuration module that's used by others. So it's fine to have a module that everybody else depends on. That's your it should be your most stable module. If you don't, if it's going to need a lot of changing, then you haven't created it well. And remember that zone of pain. So most likely your module is going to be in the zone of pain because it's not going to be very abstract and it's probably going to be very stable, but it's okay to have it. As I said, it's okay to have a very stable module. It should be very abstract. If it's very, if it's very stable, it should be very abstract. So you can extend it and use it however you need by all of your dependencies. So I generally don't see a problem with it. No. It's like a utility. You're going to have to use it. And utilities, as you've seen, are not in the clean architecture onion layers. Because yes, you're going to have these things that need to be everywhere, like logging.
Cool. I think that was that was the only question.
So the snooze fest worked.
I think you were very clear, and everybody understood what you said.
Anyway, thank you, everyone. Hope you enjoyed it, and please leave feedback. Very curious to hear what you think about the presentation.
Okay, thank you, Radu. Thank you all. I hope you learned a lot. You had a great, let's say, day until now. The next, let's say, mobile talks will be Go Beyond Swift plus Jetpack Compose in 2 hours approximately, and then Android evolutionary design and how to couple your entire system to context. So there's still some content. Also, tomorrow is another day of Programmers Week. So see you soon.